Viewers, welcome back to our channel Light to Crack Math. If you are a first time viewer of our channel, please do subscribe our channel without fail and click on the bell button to receive future notifications of our video. In our previous video, we had discussed about properties of addition and subtraction of rational numbers, and today we are going to discuss about properties of multiplication of rational numbers. If you had missed the previous video, I'll give the link of the previous video in the description and you can check it out. So moving on to the properties of multiplication of rational numbers, the very first property is the closure property. So if we are taking any two rational numbers, consider a by b and c by d, if you are going to multiply them, the product which you're going to get is also going to be a rational number. So let's check it out. So I'm considering a rational number 1 by 3 into 5 by 9. So we'll have to multiply the numerators. So 1 into 5, and you'll have to multiply the denominators, 3 into 9. So it is 5 by 27, which is again a rational number. So I'll check another example. Minus 3 by 8 into 7 by 5. So again, by multiplying the numerators, we get minus 3 into 7, and multiplying the denominators, we get 8 into 5. So it's minus 21 by 40. So this is also again a rational number. So the closure property holds good for rational numbers while we are doing our multiplication operation as well. The second property which we are going to discuss is the commutative property. So commutative property we have checked for addition and as well as subtraction in our previous video. So now we are going to check the same for multiplication as well. So consider two rational numbers a by b and c by d. So when we are going to multiply a by b into c by d, the product which we get should be equal to the product which we get when we are multiplying c by d into a by b. So let's see if this property holds good. So I'm taking an example of 2 by 3 into 4 by 5. So this is nothing but 2 into 4 by 3 into 5. So 4 2s are 8 and 3 5s are 15. So coming to the next one, 4 by 5 into 2 by 3. So this is nothing but 4 into 2 by 5 into 3. 4 2s are 8, 5 3s are 15. So both the products are the same. So commutative property holds good for multiplication of rational numbers. The third property which we are going to check is the associative property. So associative property is nothing but a by b into c by d into e by f is equal to a by b into c by d into e by f. So now let's check this with an example. Minus 4 by 3 into 3 by 7 into minus 8 by 11. So this is nothing but minus 12 by 21 into minus 8 by 11. So when you are multiplying minus 12 into minus 8, what do you get? You get 8 2s are 16, 8 1s are 8 plus 1 96, minus into minus is plus, right? And 21 by 21 into 11, when you're going to multiply that, we get 231. So let's check the other way around as well. Minus 4 by 3 into 3 by 7 into minus 8 by 11. So again this is nothing but minus 4 by 3 into minus into plus is minus, 8 3s are 24 by 77. So now minus 4 into minus into minus is plus, 4 into 24 is 96 by 230. So it is the same, right? So associative property also holds good for multiplication of rational numbers. So moving on to the fourth property, it is the property of 1. Suppose if you are going to consider a rational number a by b, then a by b into 1 will be equal to 1 into a by b, that is equal to a by b. So 1 is also called the multiplicative identity. What is it called? Multiplicative identity. Okay. Moving into the example, 92 by 365 into 1 is equal to 92 by 365. So any number into 1 will definitely give you the same number. So now let's move on to the next property. So our next property is multiplication by 0. So any number multiplied by 0 is 0. We know that, right? So what is the case if it is going to be a rational number? So even if it is going to be a rational number, it will be the same, because 0 can be written as 0 by 1 to convert it into a rational number. So now we'll multiply our numerators and then multiply our denominator. So 8 into 0 is 0, 9 into 1 is 9, 0 by 9. Any number when it is going to divide 0, you will be getting 0. So multiplication by 0 is 0. That is, the product will be 0 when any rational number is being multiplied by 0. The sixth property which we are going to check is the distributive property of multiplication over addition. So in this case, if we are going to consider three rational numbers, a by b, c by d and e by f, then a by b into c by d plus e by f is equal to a by b into c by d plus a by b into e by f. Okay, so let's check it out with an example. I'm going to consider the example 4 by 5, that is going to be my a by b, and my c by d is going to be minus 3 by 4, and my e by f is going to be 5 by 6. So first I'll check the left hand side part and then I will check the right hand side part. Okay, so moving on to the LHS. Our LHS is nothing but a by b into c by d plus e by f, right? So the a by b which I considered was 4 by 5 into minus 3 by 4 plus 5 by 6. Okay, so the LCM of 4 and 6 is 12. So this would be minus 3 into 3 by 4 into 3 and 5 into 2 by 6 into 2. So it is 4 by 5 into minus 9 by 12 plus 10 by 12. Okay, so minus 9 plus 10 is 1, right? So 1 by 12. Okay, so here it is 4 into 1, right? 4 into 1 by 5 into 12. So it is 4 by 60. Now let's check the RHS. So RHS is a by b into c by d plus a by b into e by f. So here you have 4 by 5 into minus 3 by 4 plus 4 by 5 into 5 by 6. So this is minus 12 by 20 plus 20 by 30. So the LCM of 20 and 30 is 60. So minus 12 into 3 by 20 into 3 plus 20 into 2 by 30 into 2. So it's minus 36 by 60 plus 40 by 60. So 40 minus 36 is 4 by 60. So our LHS is equal to RHS. Therefore, the distributive property of multiplication over addition also holds good for rational numbers. So the next property which we are going to check is multiplicative inverse. So the existence of multiplicative inverse. So for every non-zero rational number, a by b has its multiplicative inverse as b by a. So if this is true, what will happen is when a by b is multiplied by b by a, you get 1. Or even when b by a is multiplied by a by b, you get 1. Okay, so let us check it with an example. Okay, so 4 by 5 into 5 by 4. 4 ones are 4, 4 ones are 4, 5 ones are 5 ones are. So it is 1 into 1 by 1 into 1, 1 by 1. Okay, so what you can conclude is if a by b is the rational number, then its multiplicative index is b by a. So how you can denote this is a by b inverse. Inverse is to the power minus 1. So the inverse of a by b equal to b by a. Okay, and one important thing which you will have to note is 0 is a rational number. Why? Because you can write 0 as 0 by 1, but if you see the inverse of this, it is actually 1 by 0, which is not possible. So what you can conclude is 0 has no multiplicative index. So that's all with our properties of multiplication of rational numbers. So the next thing which we are going to discuss is the properties of division of rational numbers. So the first property which we are going to discuss under properties of division of rational numbers is the closure property. So a closure property states that if a by b and c by d are two rational numbers such that your c by d is not going to be equal to 0, then a by b divided by c by d is always a rational number. The only condition is that your c by d should not be equal to 0. Why your c by d should not be equal to 0? Again, if it is going to be 0, then it is nothing but a by b divided by 0. So you cannot divide any number by 0, right? So that is why, except for this one condition, if the values of c by d is going to be any other thing other than 0, then closure property holds good for division of rational numbers. So let's see an example quickly. 27 divided by 16 divided by 9 by 8. So this is nothing but 27 by 16 into 8 by 9. 9 ones are, 9 threes are, 8 ones are, 8 twos are. So it is 3 into 1 by 2 into 1 is equal to 3 by 2. So you can see that the answer which we have got, the resultant answer, is also a rational number. Hence closure property holds good for division of rational numbers as well. The second property which we are going to discuss under division is for any rational number a by b divided by 1 is equal to a by b, and a by b divided by minus 1 is equal to minus a by b. So we'll see an example. Suppose our a by b is equal to 8 by 21. Then 8 by 21 divided by 1 is equal to 8 by 21. So how did we get this? Because 8 by 21 divided by 1 is nothing but 8 by 21 into 1 by 1. So 8 into 1 by 21 into 1. So that's 8 by 21. Similarly, we'll take another example. 8 by 21 divided by minus 1. So minus 1 can be written as minus 1 by 1. So this is nothing but 8 by 21 into 1 by minus 1. So 8 into 1 and 21 into minus 1. So it's 8 by minus 21. Always you should not leave your denominator to be negative. So we will multiply it both the numerator and denominator by minus 1. So you get minus 8 by 21. Okay. So now we'll move on to the next property. So that is going to be our last property under division. Okay. So for every non-zero rational number, so this word is very important, that is non-zero. For every non-zero rational number a by b, we have a by b divided by a by b to be equal to 1 and a by b divided by minus a by b to be equal to minus 1. And finally minus a by b divided by plus a by b is equal to minus 1 and minus a by b divided by minus a by b equal to 1. So we are going to check all these four. So let our a by b equal to 4 by 3. So now 4 by 3 divided by 4 by 3 is nothing but 4 by 3 into 3 by 4. So that's 12 by 12, which is equal to 1. So we're getting the same answer, right? So now we'll do the next 4 by 3 divided by minus 4 by 3. So this is equal to 4 by 3 into 3 by minus 4. So this is equal to 12 by minus 12, which is again equal to minus 1. So here also we get the same answer. And the next one is minus 4 by 3 divided by 4 by 3. So this is nothing but minus 4 by 3 into 3 by 4. So it's minus 12 by 12, which is again equal to minus 1. So here also we get the same answer. Finally, minus 4 by 3 divided by minus 4 by 3 is equal to minus 4 by 3 into 3 by minus 4, which is equal to minus 12 by minus 12, which is equal to 1. So we have verified all the four results. Okay, so we come to the end of the properties of division of a rational number. So we have last one concept. Quickly we'll just go through it. So that is finding rational numbers between two given rational numbers. So this is very important from exam point of view. So please be little attentive. So this concept we'll just look into with an example. So the question is, find four rational numbers between 1 by 6 and 1 by 3. So the concept which we are going to use here is the mean concept, right? So you all know mean, right? Mean is like adding two numbers and dividing it by 2. That is mean concept. So here they've asked us to find four rational numbers between 1 by 6 and 1 by 3. So what I'm going to do is, let us consider Q1, Q2, Q3 and Q4 to be the four required rational numbers. Okay, so now you have 1 by 6 here and 1 by 3 here. So if you're going to find the mean, then you will be getting this number which is there in the center exactly. So my Q1 is going to be equal to 1 by 6 plus 1 by 3 into 1 by 2. The reason why I write it as 1 by 2 is, so you know in fraction, if it is going to be 1 by 2 divided by 2, then it is 1 by 2 into 1 by 2, right? So since we have to flip our numbers which is there after the division symbol, instead of writing it as divided by 2, I am just writing it as into 1 by 2. Okay, so now taking LCM, we have 1 by 6 into 1 by 3 into 2 into 2. So that is nothing but 1 by 6 plus 2 by 6 into 1 by 2. So this is nothing but 3 by 6 into 1 by 2. So 3 ones are 3 and 6 twos are 12. So you can actually even simplify. So 3 ones are and 3 fours are. So our middle term between 1 by 6 and 1 by 3 is 1 by 4. Okay, so now my next term Q2, what I'm going to do is I'm going to find the number between these two. Okay, so it is 1 by 4 plus 1 by 3 into 1 by 2. So now 1 into 3 plus 1 into 4 by 12 into 1 by 2. So you have 3 by 12 plus 4 by 12 into 1 by 2. So this is nothing but 7 by 12 into 1 by 2. So it's 7 by 24. So my Q3 here, this number is nothing but 7 by 24. So the next number what I'm going to do is I'm going to just find the number between 1 by 6 and 1 by 4. Okay, so to do that, my Q3 is equal to 1 by 6 plus 1 by 4 into 1 by 2. Okay, so the LCM of 6 and 4 is 12. So we have 1 into 2 by 6 into 2 plus 1 into 3 by 4 into 3 into 1 by 2. So it is 2 by 12 plus 3 by 12 into 1 by 2. So that is nothing but 5 by 12 into 1 by 2. So it is 5 by 24. Okay, so this is how you will have to find the numbers between two given rational numbers. So we have found out 5 by 24. Alright, 5 by 24. So now 5 by 24 and 1 by 4. So between these two I'm going to find one number. Okay, so my Q4 is going to be equal to 5 by 24 plus 1 by 4 into 1 by 2. So again my LCM will be 24. So 5 plus 1 into 6 by 4 into 6 into 1 by 2. So that is nothing but 5 plus 6 by 24 into 1 by 2. So that's 11 by 24 into 1 by 2. So that is 11 by 48. So we have found we have found 4 random rational numbers between the given two rational numbers, and there are n number of rational numbers between given any two rational numbers. Okay. So if this video was informative, do like our video and do not forget to subscribe our channel and click on the bell button to receive notification of our future videos, and do share about our channel to your friends so that they get the light to crack their math.